Here we are, everybody, with skydiving practice problems. So number one, state Newton's first law for the skydiver. There's so many choices. So let's see. Hey, the skydiver could be at rest and will remain at rest until acted upon by gravity, right? When the skydiver jumps out of the plane. Or it could be the skydiver is in motion and will remain in motion until acted upon by the parachute, right? The parachute or drag could be an outside force to change them really from kind of accelerating or one state of velocity to a new state of velocity, or even just air resistance, right? So the skydiver could be accelerating, right, due to gravity. So we can be specific about the motion, and will remain accelerating at a high rate, for example, until acted upon by drag, right? That could just change and reduce the acceleration rate. So any change in motion, even from constant velocity to acceleration, or acceleration to a lower acceleration, is workable for the first law because there would be an outside force changing that motion. All right, we're on to Newton's second law. And you saw these in the skydiving physics video. We did it conceptually, but now we're doing it with numbers. So we're saying that this skydiver here is 51 kilograms, which gives a weight of about 500 newtons or so. And just leaving the plane, right, no initial velocity, just the initial jump, and starts to just accelerate due to gravity. So it says, what is that resultant acceleration due to gravity right here? So we say that the net force is made up of gravity only here, and is 500 newtons from the picture over here, right? Your weight or force of gravity. So if we're going to calculate that out, we would just divide both sides by 51 to solve for acceleration here, right? So that would give us an acceleration rate of, I'm doing it right now, this is live, everybody, 500 divided by 51 gives me, oh, guess what? About 9.8 meters per second squared, right? And right now we're saying downward is positive, I guess, right? And that's fine to do. We just know this is downward acceleration. All right, keep on rolling, everybody. Let's see, number 3. So we keep falling a few seconds later, and now we have a velocity of 30 meters per second. But now there's air resistance, right? There's gravity pulling us down at 500. Air resistance has built up to about 100 newtons. So net force here is the combo between gravity and air resistance is going to cause us to accelerate. So that's what Newton's second law says. So if we put in those numbers, we have 500 newtons for gravity, 100 newtons of air resistance. So now our net force is not 500 as it was up here. It's a bit less. So it looks like it's going to be 400 newtons. Sorry, I'm writing over these numbers. Okay, so there's my net force now, equals 51 times acceleration. So if I divide both sides by 51 again, I'm going to get a new acceleration rate. So 400 divided by 51, again, we're doing it live, everybody. 7.84 meters per second squared. Still down, but our acceleration rate is less now, right? We don't accelerate at 9.8 because gravity is not the only force acting on us. We have a bit of air resistance. So again, our net force is 400, resulting in a lower acceleration rate. Skydiver is still gaining speed, but not at as high a rate as when we just jumped out. All right, let's carry on to number 3. I'm scrolling up, everybody. Or actually number 4, right? All right, we'll get 4 and 5 on here. All right, so it says a few more seconds pass. And we continue. Air resistance is increasing, right? So now we're up to 400 newtons of air resistance. Have you noticed, our speed is increased. That's fine, because we were going to keep gaining speed as we fall. We're accelerating after all, albeit at a lower rate. So now air resistance has built up it went from 100 newtons to 400 newtons, right? The longer you fall, the higher air resistance goes. So we're looking here then and saying, well, the net force on us is gravity minus air resistance. Gravity minus air resistance up. But we have new numbers now. So gravity is still constant, right? That's just our weight, still 500 newtons. But now we have 400 newtons of air resistance. So our net force now is 100. Much lower net force. Looks like we'll still be accelerating, but at a much lower rate. So if we divide by 51, we're going to find a much lower acceleration rate here. And that acceleration rate will be, so 100, that's going to be less than 2, everybody. So yeah, about 1.96 meters per second squared. So we're still accelerating, but at a much lower rate. Now we keep falling, and as you guys have seen, we keep falling here. Eventually, air resistance is going to max out to equal the force of gravity or your weight. So here we had 500 newtons of weight or gravity, and now air resistance has reached that max and has balanced out the force of gravity. We're still falling. You notice our speed's higher because we were still accelerating before, and we're still falling. But now if we look at our net force, it's gravity minus air resistance again. We'll produce our motion here. So we want to see what our motion is. So 500 newtons of gravity, but now air resistance is also 500. So the net force is 0. So 51 times acceleration rate, what gives us 0 here? Well, 51 times 0 is going to give us a net force of 0, right? So we see that our acceleration rate here is 0. Now we're still falling. So that just means that we're falling at a constant velocity, right? We're not gaining speed or increasing speed anymore. We're falling at a constant velocity. And when we talk about this with skydiving, we call that terminal velocity. So the skydiver is just going to keep falling at that rate. If in fact it is 60 meters per second, as it showed up here, the skydiver is just going to keep falling at 60 meters per second the entire time until they do something else. Otherwise, we need an outside force to change their motion. Well, we are going to do that because the skydiver is going to pull the chute. And so here we go, open the parachute, everybody. And we have a huge force of air resistance now. That chute is going to catch a lot of air and really ramp up our force of air resistance here. So if we look at our net force again, we still have 500 newtons of gravity. Our weight does not change, but 2,000 newtons of air resistance. So yeah, this is going to be a negative number, right? Negative 1,500 newtons is going to be our net force. But this negative number sign just means upwards, okay? So we're going to have an acceleration rate going upwards now. And so again, if we divide both sides by 51 to get acceleration all by itself, that's going to be about 10, I think, everyone. 1,500? No, I lied. 29. So we have an acceleration rate of 29.41 meters per second squared, and that's going to be upwards, right? I can leave the negative sign there, it doesn't matter, as long as we know it's upwards, right? Because we're going to be slowing down, right? And that's a huge slowdown, right? Because remember, gravity only pulls us at 9.8, so that's 3 times the amount of deceleration, I would say, right? Okay, let's keep going and see what happens if we keep falling. A couple seconds later again. So here we go. So air resistance is now reduced. And now it's the same as the weight again. And that's what air resistance does, right? It always wants to balance out the force of gravity. It can be greater than that or less than that, but in the end, the force of air resistance will eventually balance out your weight. And we see our velocity is greatly reduced, now only falling at 2 meters per second. So the parachute did its job. And we're looking at the force of gravity minus air resistance as our net force again to figure out what our motion is. So you can probably take a guess from the last time. So 500 newtons of gravity minus our new 500 newtons of air resistance provided by the parachute gives us a net force of 0 again. So we're falling at a constant velocity again, right? That's another acceleration rate of 0, which means we're falling at a constant velocity, and thus a new terminal velocity, which is much lower than the last one, but still terminal velocity, and we will land gently on the ground. That's just about 5 miles per hour, everybody, so we'll be okay. All right, state Newton's third law for the skydiver. Again, so many choices. It could be that the skydiver pushes on the air, and the air pushes back on the skydiver. Let's see, it could be, I'll do another color. It could be that that gravity pushes or pulls on the skydiver, which is actually the gravity from the Earth, right? And the skydiver pushes back or pulls back on gravity, or essentially pulling back on the Earth, really, right? It could be the parachute pulls on the skydiver, and the skydiver pulls back on the parachute. So a lot of different examples there. All right, everybody, thank you for checking your answers to the skydiving practice problems.